We are going to be covering the filtering elements in DX. There are two different kinds of filtering in DX. We have our digital filter right here and our peak filter right here. The digital filter occurs on the time domain data, and the peak filter is a noise flagging element that occurs on the peak output from the advanced digital signal processor. We'll start by talking about the digital filter. There are four main kinds of filters available in the digital filter. We have the spike filter, the FIR filter, IIR filter, and half power. We also have a thermocouple and window stats plugin here that do a couple of different operations to the channel. If you'd like more information about those, please reach out. We are just going to be covering the first four filters today. So I already have a FIR filter set up here. The way that these are all set up is by using arguments here for how the filter is going to be applied. So all of the syntax for these filters is available here in the description area. I encourage you to go ahead and read through this. For this filter, for instance, I have a notch filter with the PM prototype, which is just the type of filter that is being applied to the algorithm. I have the order, which is the number of taps in the filter, and then I have my minimum and maximum for that notch filter, and then I have the tuning, which again has to do with the algorithm. And again, you can read more about all of that down below. So this basically is just going to apply a notch filter between 1000 and 2000 on my frequency. Also, again, that is being applied to the time domain data. Next, we have the peak filter. The peak filter does not directly remove filtered peaks. Instead, it tags them so that they can either be included in further downstream processing or not, or removed from a Campbell diagram or shown on a Campbell diagram. There are 13 of these different noise plugins available. The description box has setup information and information about each one of these plugins. Right now, I have a NIV plugin selected, which will just flag all of the non-integral noise here based on my arguments that I have set up. Here in the viewer, we can see the results of my design. We have the Campbell diagram here with that filter between 1000 and 2000 hertz. And we have in red all of the integral noise or non-integral noise that was flagged. If I right click and go to plot options in the Campbell settings area, I can see here there is a draw noise checkmark. And if I uncheck this, it will remove that selected noise from the Campbell diagram. I will briefly cover the other three digital filters in a little bit more detail. The spike filter here creates a nonlinear digital filter for removing short duration spikes from the input signal with different arguments here that you can select based on the type of noise that you have present in your signal. The IIR filter is the infinite impulse response. This does functionally the same thing as the FIR filter, however, it does not maintain phase, so that's just something that you should be aware of whenever you're using it. And finally, we have the half power filter, which is a routine that seeks to find spectral peaks that are sufficiently above the noise floor.